Today's video will be dealing about the reaction of chloroform with silver powder, oxygen or air, conc HNO3 and acetone. Next, we'll be dealing about formation of chloral, formation of DDT using chloral and chlorobenzene, Sandmeyer reaction, Grignard reagent formation and its acidic hydrolysis, Friedel-Crafts alkylation and acylation reaction, Wurtz-Fittig reaction, and resonating structure of chlorobenzene. So all these reactions are the most important reactions which are usually being asked in your NEB board examination. The very first one we need to deal with reaction of chloroform with silver powder. So how exactly chloroform? What exactly is chloroform? Let's go for it for the very beginning. So chloroform is CHCl3. So how is it being treated with? The very first one I need to treat it with silver powder. So what will exactly happen if we have this thing? If we have a molecule of chloroform that is CHCl3, and if there are two Az group, and again there is carbon with one hydrogen and remaining three chlorine group. So the product those formed will be ethyne. What will exactly happen is, sorry, there will be six molecule of silver. This six molecule of silver will take away the six molecule of chloride, six chloride atoms, in order to form six AzCl molecule, along with the liberation of CH being connected with the other CH to form ethyne. So basically what you need to remember is when chloroform is treated with silver powder, ethyne is formed. Next we have the reaction with conc HNO3. Conc HNO3. So what exactly happens when chloroform is being reacted with conc HNO3? So we can break down conc HNO3 as, let me again take carbon being connected with three chlorine and one hydrogen. And if it's being treated with concentrated nitric acid, conc nitric acid, let me write it as OH and NO2 group. What will right happen over here is this OH group and this H group will together come out in the form of water. Okay. So what will exactly be formed is there will be the formation of C. The entire three chlorine will remain as it is, and here there will be the attachment of NO2 group along with the liberation of water. So this molecule those formed is known as chloropicrin. We call it chloropicrin, or you can also call it trichloronitromethane. This is our nitric acid, concentrated nitric acid, and this one is your chloroform. Okay, so let's move on for the next one. Number three, that is the reaction with acetone. Action with acetone. So basically, when chloroform reacts with acetone, this one is chloroform, Cl, Cl, Cl along with the H. And the other group that we have is acetone. Acetone seems something like this, C double bond O. And other than this, there are two CH3 group attached with this carbon. So this is basically your acetone. And this one is your chloroform. When they are treated together in the presence of KOH, what will exactly happen is the double bond between carbon and oxygen will break. The oxygen will get a negative charge and the carbon will have a positive charge. Here, what will happen is this bond is going to break. The hydrogen will have delta positive charge and carbon will have delta negative charge. Now, what will exactly happen is this part, this hydrogen will go and attach right with this O group, and the carbon will move and attach with this carbon. So the product those formed in this is C already has two CH3 group. Other than this, it was having a O, now which consists of a new H group being linked with it. This H is being linked with this O. ये H जो है ये इसके साथ जाके link हो जाता है. Now this carbon is being connected with this, that is this contains CCl3, and this is what we call chloraton. Chloraton, or we also call it trichloro, sorry, 1,1,1 trichloro 2-methyl propane 2-ol. So better you remember chloraton. In most of the place you will find the word chloraton. So how is it formed? When chloroform is being treated with acetone, chloraton is being formed. When chloroform is being treated with nitric acid or concentrated nitric acid, it forms chloropicrene. Next, we have action with air. Or sometimes the question might come that why is chloroform being stored in dark colored brown bottle or completely filled dark colored brown bottle? Such type of question generally used to come. So you need to reply. Next, we have action with air. Action with air, or I can say oxygen. So basically, if you have chloroform, again you will have Cl, Cl, and Cl group having a H group, and you need to treat it with oxygen O2 in the presence of light. So basically, the reaction takes place in the presence of light. So generally, it is being stored in a dark colored brown bottle. So what will exactly happen in this scenario is one of the H group, here you can understand it in this way. One of the Cl group and one of the H group, they will come out together in the form of HCl. Next, you have a carbon C. Then, other than that, what will happen is already there are two Cl being attached with it. And this oxygen will attack this carbon. And here will be the formation of double bond O. This is what we call carbonyl chloride. Carbonyl chloride, or we also call it phosphozine. So let's move on for the other questions. That is your, the second we might have formation of chloral. Number two, formation of Sometimes it can be asked. Formation of chloral. So what exactly is chloral? How can we prepare chloral? So this is a question generally. How can we prepare chloral from ethanol used to come generally? Okay. So what we basically have is whenever we have ethanol molecule CH3, CH2, OH. So this is your ethanol. And along it with it, we need to treat it with chlorine. So what is exactly going to form is this will be transformed into. There are two chlorine molecules. So what it will exactly happen is it will take one of this hydrogen and one of the hydrogen from this carbon. So that there will be the liberation of two molecules of HCl. And other than that, there will be the formation of CH3. And this group is gonna transform into aldehyde. That is, this will be transformed into C double bond OH group. That is, it will turn into ethanol. The ethanol will transform into ethanol when it is being treated with the chlorine. Okay. Next, what you need to do is whatever the ethanol you those obtained, the ethanol obtained in the first step, that is CH3, C double bond OH. Okay. It's being again treated with chlorine. And what will exactly happen again is the entire three hydrogen atom with this carbon will be replaced by three chlorine. Mean the molecule those form will look something like this: C double bond O H, and the other carbon has three chlorine: Cl, Cl, and Cl, along with the liberation of three molecules of HCl. That is, this one is your chloral. Right? So ethanol is being treated with carbon to convert it into ethanol, and then it is again being treated with the chlorine. Sorry, ethanol is being treated with chlorine to form it as ethanol, which is again being ethanol is being treated with ethanol is again being treated with the chlorine to form chloral. So this is what you need to remember, right? From ethanol, it is being treated, converted into ethanol, and then again ethanol, it is being converted into chloral. And in both the time, it's being treated with chlorine. So this is how chloral is formed. It might be asked, or sometime what exactly happened is, how do you prepare DDT from chlorobenzene and chloral? So that can be the question. Sorry. There we have question. We generally get a question like, how do we prepare or formation of DDT using chloral. So whatever chloral we made right now, the same chloral and chlorobenzene and chlorobenzene. So using this two, we need to prepare DDT. Basically, it's a manufacturing process of DDT in which chlorobenzene and chloral is being used. So how are we going to make this? So let's go for this one. It's a very important reaction. It's generally being asked in 2 mark question. So what we need is we need chlorobenzene. So you might be known what is chlorobenzene. So chlorobenzene is something like this, benzene having a chlorine group. Let me take clue to chlorobenzene. And what you might be very clear is, other than this corner, all the corner have one of the hydrogen atom because it's C6H5Cl. So all the corner must contain one of the hydrogen atom. Let me put a hydrogen. Let me put a hydrogen here. And it is being treated with C and how many chlorine? Cl, 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 and there you have C. So we already got that. And there is H, there is double bond O. So what will exactly happen is this O will take away this two hydrogen this two hydrogen, and what it will form is water will be liberated right there. The reaction takes place in the presence of conc H2SO4. What will come out? So H2O or water will come out. This two hydrogen and this one oxygen will liberate as water. And the remaining group, that is, it seems something like this C. Remaining, it has C. And how many chlorine are there? Cl, Cl, and Cl. Other than that, this second carbon has one hydrogen and it is being attached with, or you can mark it something like this. Sorry. Let me put the hydrogen right here. And one of the chlorobenzene is upside over here. It seems something like this. One of the chlorobenzene came here and the other chlorobenzene came here. And this is what we call DDT. Or we can also call it, or simply mark it as DDT. Next we have Sandmeyer reaction. Sandmeyer reaction. Sandmeyer's reaction. So what is Sandmeyer reaction? Again, Sandmeyer is a very important one. All these questions are must-asked question. So Sandmeyer reaction basically means how you convert diazonium chloride group into chlorobenzene. Basically, it's a technique for the preparation of chlorobenzene. Okay. So you might be known, I think, how to prepare benzene diazonium chloride. Okay. So if it's been given to you, if you have a benzene ring and a diazo group, that is N2Cl, and if it's being treated with Cu2Cl2 in the presence of HCl, acidic medium, what will exactly happen is this two nitrogen will liberate in the form of nitrogen gas. This will come out in the form of nitrogen gas. This, sorry, and this chlorine will come and attach right at this point to form chlorobenzene. Sorry, yeah, chlorobenzene. And what is this? Benzene diazonium diazonium chloride. So what basically is Sandmeyer reaction? So you can remember the process of conversion of benzene diazonium chloride into chlorobenzene in the presence of Cu2Cl2 and HCl is known as Sandmeyer reaction. I believe you will be able to remember this much. It's quite easy. Let's move on for the next one, that is the method of formation of Grignard reagent and acidic hydrolysis of it. Formation of Grignard reagent and its acidic hydrolysis. Acidic hydrolysis. So whenever you get an alkyl halide group, that is RX group, and if it is being treated with a magnesium in the presence of dry ether, it form RMZX. That is what we call alkyl magnesium halide. This is your alkyl halide. Okay. It's being treated with magnesium in the presence of dry ether to form alkyl magnesium halide. This is what we call Grignard reagent. Okay, so this is how we can prepare when alkyl halide is being treated with magnesium in the presence of dry ether. Grignard reagent is formed. So this itself is your Grignard reagent. Okay. Now we have what will happen if I'm going to treat it under acidic hydrolysis. So basically now I have R, Mg, X group, and I need to go under acidic hydrolysis. So I need to treat it with water and the acidic medium. So what will exactly happen is you might be very clear that if a bond breaks right from this point, the magnesium will have a plus charge and R will have a minus charge. If this breaks at H plus and OH minus, the magnesium part, this group will carry away the hydroxyl portion, and the this H group, this one, will go and attach with the alkyl chain. And it will basically form R or alkane along with the liberation of magnesium hydroxyl halide. So basically what is formed is alkane is formed. So if alkyl halide is being treated with magnesium in the presence of dry ether, alkyl magnesium halide or Grignard reagent is formed. And if it is further being hydrolyzed in acidic medium, it will give you alkane. Now, to very common reaction, that is Wurtz-Fittig reaction. Wurtz reaction and Wurtz-Fittig reaction. Let's go for that as well. That's quite easy. We have already did about Wurtz reaction, so I believe you'll be able to do this one as well. So we have Wurtz-Fittig reactions, 5, 6. So we have Wurtz Wurtz Fittig reaction. Wurtz Fittig reaction. So basically in this one, we need a alkyl halide group. Okay. And again it's being treated with sodium metal. And the other need to be aryl halide or chlorobenzene. Okay. So one need to be alkyl halide. One is alkyl halide. And the other is aryl halide or chlorobenzene. And this is being treated in the presence of, you already know, it will be treated in the presence of dry ether. What will exactly happen? This halide group and this Cl will be taken away by the Na, and there will be the formation of R being attached with the benzene ring. So this is what we call Wurtz-Fittig reaction. During Fittig reaction, if we have only Fittig reaction, only Fittig reaction, so basically what will happen is there you will have a chlorobenzene. Again, there will be two sodium metal. Again, you will have chlorobenzene. So during Fittig reaction, both the chlorobenzene will be there. During Wurtz reaction, both alkyl halide will be there. And during Wurtz-Fittig, one alkyl halide and the other aryl halide will be there. One alkyl group and the other aryl group will attach. And here the situation is one is alkyl group and the other is aryl group. And if these have a connection, that is known as Wurtz-Fittig. And if both the aryl group are there, that is Fittig. If both the alkyl group are there, that is Wurtz. So this chlorine, sorry. So here we have two Na. So this 2Cl will be taken away by the 2Na group. Again, the reaction condition is same, that is diether. What will happen? The two benzene ring will attach And this reaction is known as fatigue reaction, or this will form diphenyl. Okay. Now let's move on for the last reaction, that is Friedel-Crafts alkylation and Friedel-Crafts acylation reaction. What is Friedel-Crafts? Friedel-Crafts alkylation and acylation reaction. So if there will be the attachment of alkyl group, so that is alkylation, and if there will be the attachment of acyl group, that will be acylation. Okay. So what we basically have is we have a chlorobenzene, chlorobenzene, and if we are treating it with alkyl halide CH3Cl, in the presence of necessary condition is like in Woods reaction, like in Grignard reagent, there was a necessary condition that is dry ether need to be there. For this, we need anhydrous AlCl3. So now what will happen is here there must be hydrogen. So this hydrogen will be taken away. This hydrogen will be taken away by this chlorine, and they will come out as HCl. Now what will happen is this CH3 group will go and attach right at this place, and it will look something like this. Here you will have Cl and here you will have CH3. Or you can also have Cl, and here in the para position you might have CH3. Next, if you have an acyl group, that means somehow something changed. And if we have CH3, C double bond O, Cl, in the presence of anhydrous AlCl3. So what will happen in this as well is this bond will break right from here. The chlorine will be taking away the hydrogen, and this remaining part will move and attach at this point. That is, the product formed will be something like this. So we'll have Cl, which was already there, and here will be the attachment of COCH3. Or we can also make it like here you have Cl and here you have COCH3. So this is how the reaction or products are formed. We can name it as 2-chloro toluene because benzene with CH3 is known as toluene. Or we can call it 4-chlorotoluene. For this, we can call them orthochloroacetophenone, chloroacetophenone, or we can call it para-chloroacetophenone. Generally, keep in mind that the para products are the major products because there is less steric hindrance. So if you will have any queries right with this, please make sure that you'll be asking me write it in the comment section. Other than that, I will try to attach some few questions right beside. Kindly solve them, and if you'll be able to solve it, attach it in the comment section.